This video is going to go over the 3 problems of free body diagrams. Some of you already took this quiz, but I would like you to still watch it to see what mistakes you made or how you did on it. For the rest of you, your free body diagram quiz tomorrow will be very similar to these 3 problems. If you want to take notes while the video is going, you can. First thing we need to look at are all the requirements that we need to include when we are using a free body diagram. That information is highlighted up here in the top area. The problem itself says, a bowling ball is rolling across the floor to the left with a force of 125 newtons. For that, we are going to go ahead and draw an arrow to the left. Remember, the vectors always need to come out of the box. We are going to label it with 125 newtons. And then we also need to apply or label what type of force that is. That is going to be applied force. Next part of the question says, friction with the floor is 50 newtons. For this, we're going to draw a vector the opposite direction of applied force, 50 newtons, and then we are going to label it with friction. One important thing to remember is that friction always works in the opposite direction of applied force. So it's important that you don't draw your friction arrow coming from the bottom of the box. Next it says gravity and the normal force are 10 newtons each. Well, for this we know gravity pulls an object down. This is 10 newtons. We're going to label it. And then normal force pushes up on a surface. So for that we're going to draw the arrow coming up. 10 newtons and label it normal force. At this point we still have to make sure that we calculate the net force. In order to do this, we need to do a couple different things. First off, we need to look at opposites. So if we first look at this area right here, I see 10 newtons going up and 10 newtons coming down. When arrows are working in opposite directions, we subtract. So that means 10 minus 10 equals 0. So this bowling ball is not going up or down. It's balanced. It equals 0. So we don't need to include any of that in the net force. So technically, we are no longer looking at these two numbers. Now we have 125 newtons to the left and 50 newtons to the right. What we do here, since they are working in opposite directions, is that we subtract again. 125 minus 50 is 75. And then the last part is we need to identify which way the object is going. In this case, since 125 is a larger, it means that the bowling ball is going to the left. This would be your net force. Finally, the last part of the question says, are the forces balanced or unbalanced? Since we have a number of 75 newtons to the left, this object is in motion, which means that the object is unbalanced. This problem says a dog is chained to a tree sitting in the backyard when it sees a squirrel. The dog races towards the squirrel with a force of 200 newtons. Since the problem doesn't give you a specific direction as far as left or right, you can go ahead and choose. In this case, I'm going to go ahead and draw this one to the right. 200 newtons, and I'm going to label that with applied force. It says friction with the ground as the dog is running is 25 newtons. One mistake that I've been seeing a lot is that students are putting friction with the ground pointed towards the ground. Remember, friction always works in the opposite direction of applied force. So in this case, it's important that you realize your arrow should be going to the left against the 200 newtons. So this is 25, and we're going to label that with friction force. The next part says the force of the tree pulling on the dog is 125 newtons. The tree is pulling on the dog, so it means it's going to go the opposite direction of the dog. We're going to label that 175. And again, we're going to put that as applied force. Before we find the net force, we have a couple things we need to look at. First of all, we have arrows that are going in the same direction. When we have arrows going in the same direction, we add those two totals. So 175 plus 25 is actually 200 going to the left. Now if we look at our situation, we have 200 newtons going to the right, we have 200 newtons going to the left. When we have arrows going in the opposite directions, we subtract. So 200 minus 200 is 0 newtons. That's our net force. Because the object is not moving, you don't need to provide an arrow in direction. So 0 newtons is our net force. Finally, it asks if the forces are balanced or unbalanced. In this case, the dog is not moving, so that means that the forces are balanced. Anytime the net force equals 0, the objects are balanced. The last part of the question says, does the dog have enough force to break free from the chain? Since he's not moving, no, he does not have enough force to break free. For this last problem, it says car number 1 is traveling to the right with a force of 750 newtons. Car number 2 is traveling to the left with a force of 600 newtons. Friction with the ground is 50 newtons. Calculate the net force left over when the two vehicles collide. You may find it helpful to draw two separate boxes. This problem could be drawn with one or two boxes. I'm going to start with car number 1. Car number 1 is traveling to the right with a force of 750 newtons. I'll label that 750. And that is applied force. Car number 2 is traveling to the left with a force of 600 newtons. Friction with the ground is 50 newtons. This is where it's important to remember that friction's acting on both cars. So I need to include on both sides 50 newtons and friction. Now we need to calculate the net force. First thing we're going to look at are the arrows for friction. We notice that both of these are going in opposite directions. So 50 minus 50 equals 0. So we no longer really need to look at these two numbers. Now if we look at our applied force, we have 175 newtons going to the right, and we have 600 newtons going to the left. Because they are going in opposite directions, that means that we subtract. So we get a total of 150 newtons. Because the applied force is stronger at 750, the object is going to be moving to the right. One other way of looking at this with one box could be 750 to the right, .600 to the left, and then we need to remember that friction is acting on both cars. So this 50 that I just drew is working in opposite direction of the 600, and then this 50 is working in opposite direction of the 750. So same way that we did the top one, you could say 50 minus 50 equals 0, and then 750 and 600 is a 150 difference. Either way is fine. You're more than welcome to do 2 boxes or 1, whichever helps you to see the problem. The free body diagram quiz tomorrow will be very similar to these 3 problems. Make sure you use these 3 problems as a reference to study tonight. Also make sure that you apply the different types of force to your free body diagrams and label them.